welcome. For some people, welcome back. For the presentation of the Circtex project, I forgot the pointer. There we go. This is a Northwest Europe NWE project on textiles, and within that region there's 17 million tons of non-renewables used every year. So there's a more focus on the circular economy, especially from Europe on, otherwise you would not be here either. So we saw the necessity to develop technologies for closed loop within workwear. So we started the Circtex project with a focus on the development of a circular polyester workwear garment. So that is fully recyclable and recycled, because a lot of companies promise to recycle it. We will, within this project, recycle it. So what are the objectives of the project is to mechanically and chemically recycle polyester. We will do both. So mechanically is actually the thermomechanical recycling. We will improve it, and then the chemical recycling is actually the upscaling of that technology. We will improve the spinning and the weaving. We want no waste within the production, or limit the waste as much as possible. We will implement the wear to yarn to dismantle certain aspects on the garment and build an industrial microwave for this assembly. So this is also upscaling. And we want recyclable laminates, logos and accessories to develop them, so that they can recycle as well with the garment. And then we want to build up a logistics system to collect and to sort the textiles. The project started in January 2020 and will then end in June 2023. The partners are Modint, which most of you will know, and they are the responsible and the lead partner within the project. Centexbel, the company I work for, we coordinate the R&D activities and will also do the necessary certification, because it's PPE garment. You need the CE marking and the certification, and we will also do the Ecotex certification of the recycled garment. Antex, which is a polyester filament producer and will present later on as well, is developing the mechanical and chemical recycling technologies for polyester fabric. IBQ, which also is a Spanish company, is weaving, dyeing and finishing the fabric of those recycled yarns that Antex will produce. Then you have Hydroware, who will put together the garment. So they will make the garment according to the eco-design specifications that Groenendijk is or has developed already by now. So Groenendijk is in charge of the circular design and also the testing phase of the garment, because we want to test the garment, also to contaminate the garment and to check if these contaminations can be tackled within the recycling, or with the recycling technology that we want to use. Then JNA, they will develop labels that can be recycled, so transfer logos. Where to Go is further developing their yarn that dissembles under the influence of microwaves, is building the microwaves so that it is marketable, so that you actually can on industrial scale disassembly garments. And then we have Euromaterials, who is decimating or helping us to decimate the findings of this project within the region. So the results will be shared and communicated within the region, and we hope to increase the number, certainly, of SMEs and also other enterprises to implement in their system or for their product the circular economy. That is one of the important objectives. So we are convinced that Circtex will stimulate the growth in the textile industry, certainly regarding circular textiles, and create jobs within that. Then this is where you can find information, and I leave the floor to John, who will explain you more what Where2Go is doing within the project.
I will try, for sure. Thank you very much. Thank you, Edwin, for explaining the circular textile project, but also the progress in the project, of course. My name is John Beelen. I'm responsible for Where2Go, and try already for a couple of years to contribute to a more sustainable textile industry. And again, what I do is, together with Where2Go, find new innovations and try to implement new innovations. And the Where2 yarn is such of that new innovations. We are in the project with 9 partners, as you all know, as Edwin already told. But it is too short, 20 minutes, for every partner to tell their story. So Marta and myself was asked for at around 7-8 minutes to explain a little bit more about what we are doing, about our project and our evolution, and what the results are now in this stage. So after me, Marta is responsible for Antex, and Antex is in the project responsible for the chemical or mechanical recycling and the spinning process. And every partner is complementary in the system, of course. And we are two partners who are going to explain their specific part. In our case, maybe it's not mentioned, but we are focusing on RWS clothing, which is made of 100% polyester, but it's very difficult clothing with membrane, with also seam tapes, with high-vis tapes and all that kind of things. So it's a very difficult one, and I can tell you, and if you look to this picture, for instance, an awful lot of this clothing is used in the world, and an awful lot of this clothing is ending by end of life in an incinerator or in landfills. So that means an awful lot of waste of resources, but also an awful lot of waste not waste, but an awful lot of pollution. So we have to solve this problem, and one of the things is an awful lot of this kind of clothing, looking to, for instance, the high-vis striping. If clothing has high-vis striping, it ends, what I already mentioned, it ends normally in the incinerator, because you can't do anything with it. The only thing what you can do is to disassemble the striping. But as we all know, it's very difficult to disassemble because you can do it by hand, you can do it by a torsion knife and all that kind of things, but it doesn't work. It's too expensive. So a couple of years ago, Where2Go developed, together with some companies and partners in the UK and Germany, a specific yarn. And I'm going to tell you a little bit more about the yarn, but with that yarn, we can do it very fast in an industrial way, based on industrial volumes. And I'm going to show you. But again, with scissor, with torsion knives, etc., some companies are doing it now for the moment. It doesn't work, I can tell you. Okay, the responsibility of Where2Go now, what I already mentioned is we already have an existing Where2 yarn. That Where2 yarn was not completely perfect. One of the things which must be improved was, for instance, the sewing speed. When we are going to the industry, it's really necessary that the industry can work with speeds, of course, which are almost equal as what they are using for that moment. And I can tell you for now, the yarns we have developed now can be sewn with a speed of at around 85–90%. So we made very great steps. But for the details, I come a little bit later. So the responsibility in the project, in the Circtex project, is to disassemble all mixed materials, not polyester. As what I already told is we are working with 100% polyester in base. So when a seam tape is not polyester, or when let's say a label is not 100% polyester, or when we are using, let's say, an RFID tag and it's in a pocket in the clothing, for instance, it has to be out. Also stitched with wear too, it could be possible that pocket can put out. So the role of wear two in, let's say, this project is to disassemble all mixed materials which could disturb the upcycling process of polyester. That's one thing, and the other thing is to create, let's say, infrastructure. It's not only that we are going to do it, let's say, only in Holland. No, we like to roll it out in a European way, and we like to roll it out, of course, also to the big waste process companies, if we look to where to go in this case, let's say to the Suez and the Veolias, etc., etc. So we have to try to roll it out. So that's also one of my concerns now. And we have to roll it out. If it really works in, let's say, this project, we have also to roll it out. No, it's not a matter of we have to do it, but maybe we can be helpful for other industries like, let's say, the mattresses industry. They have the same problems now for the moment. They are also working with mixed materials, and also there it's very difficult to disassemble. And again, you can do it in a manual way, or you can do it by force, but it is not an industrial way. So in the mattresses industry, also they are very interested in the solutions we are creating now for the moment. But that's the same with shoes, that's the same with the fashion industry, etc. So we try to roll out our lessons learned in this concept. So the Wear 2 thread family, that's where it all started, is almost ready. Almost ready means that our goal was to create sewing yarns, because it's a sewing yarn, eh? No doubt about it. It's not for weaving or etc. It's a sewing yarn. The beginning was the Wear 2 thread family. In the beginning, it works perfectly, but some improvements were necessary, and we are now at this moment in the stage that it is almost ready. So almost ready means 4 different yarns, similar with the regular yarns as used in the clothing industry currently. So that means for the insider, that means an 80 diameter, or number 80, a number 50. When I look to Dtex, for instance, 460, 310. But we also have developed a 50 diameter, so more for the heavy applications. Think about the shoe market, for instance. Think about heavy clothing, winter coats and all that kind of things. But we also designed a multi-norm yarn. So that means chemical resistant, heat resistant. So specifically looked to, let's say, the workwear. A big part of the market in workwear is also based on, let's say, heat resistant, chemical resistant, etc. So also a Wear 2 yarn will be ready within the coming next month as a multi-norm yarn. And I can tell you, it costs an awful lot of money, it costs an awful lot of time. We are working together with some knowledge companies in the UK, but also in Germany. It costs an awful lot of time, but it is ready. So that means the yarn in look, in feel, exactly the same as the current used yarns, passes all required tests, and that's really necessary. Washable, strengthness, all that kind of things. It is, and that's of course very good to know, it's as strong as any other yarn. And I can tell you, mostly it's stronger. And in this case, it's almost ready, what I already said. The characteristic of the yarn is that it is made of recycled polyester from the outside. So that means what you see is polyester. The filament are polyester, but the inside, that is where the magic happens. That's another composition of materials. And I can tell you, Thunderon is one element in it, but added with some other materials. And the specific thing of the yarn is that when you put it in a microwave, after 60 seconds, the core will break, and everything what is stitched with this yarn it can be disassembled. And it can be very, very fast. I can show you in a video within a moment. If we have created the yarns, as already told, of course, also the technology is necessary in case of the microwave. And we started with a very small microwave in the beginning, a couple of years ago. We have lessons learned. We can tell you it really works. And I can tell you, we are now busy. We created this microwave. We engineered it, and it's already built now for this moment in Belgium. And it will be ready at the end of this year. And I can tell you, the capacity of this machine is at around 7,000 tons per year. And we can increase it until 15,000 tons. And it depends a little bit on the shifts we are going to use. So an awful lot is possible. And it's a PLC-based system, so that means driven by information on an RFID chip. And that RFID chip, I'm coming later on. So it's going to be this machine in Atelier. We are going to create our own separation hub as a kind of a demo to convince the Suez and Veolia from this world. And we are going to do this with a company where employees are working with a distance to the labor market. So the job we are asking can be great done by that kind of, let's say, industries or companies. What we also are doing is creating a kind of a platform, our own platform. And that will be the where-to-go materialsexchange.com platform. What we will do is, of course, starting with eco-design / circular design. Not only a matter of thinking about the materials, but also how can we disassemble, of course. That's very necessary. Think about it. All that information we put in a digital passport, a materials passport. And there's going to be an awful lot of information. Because in the next coming future, transparency will be necessary in the textile world. And consumers, governments will ask transparency. So an awful lot of information will be behind it. That means origin of materials, the context of the materials, all that kind of things. That will be put into, that information will be used for a QR code to convince the physical wearer. So with his cell phone, he can read the QR code, and there he can also find some instructions what to do by end of life and all that kind of things. But another thing, and maybe more important, is the RFID chip. We are transforming all this kind of information to an RFID. And that RFID is for us necessary in case of track and trace, or by our own system, or of course by the Suez and the Veolia. If they have the reader, the right reader with the right software, they can read all our information. But also the machine, the microwave you have already seen, is driven by the information on the RFID chip. So why wait is a little bit our conclusion now. That means it's already available within a couple of months. And that's the role of where to go at this moment in the project. Now I'd like to give the word to Marta. The floor is yours. Thank you.
Thank you very much. Good. Well, we as Antex, as John explained, so we are the filament producer, and in this project we are taking part also for the recycling of the materials that will arrive to us, both post-industrial and post-consumer. So, as we say, so first it will be also the characterization of the textile waste, because it's very important to know what we have. Depending on the type of waste, we will be able to perform one type of recycling or the other. Then to decide if it will be mechanical or thermomechanical, because we are talking mainly about polyester, which is a thermoplastic, so we are going to do it by means of thermomechanical recycling or chemical recycling in case we cannot do it in mechanical recycling. Then we will have to do the recycling of the post-consumer workwear garments and the post-industrial waste generated to produce it. So sometimes we think only on the final product, but we have to think that to produce all those garments, all those materials, the whole industry has waste all around. So we as filament producers, we have waste. Weavers have waste with the selvages. The cat and sew has big amounts of waste. So if we are able to collect all this, we will be going to zero waste production systems and to a circular economy. So we as textile producers, we have to be aware that we are part of the textile industry, so we are also part of the problem if we generate one. So all us from filament to end product, we all have to be together and aware and responsible of the waste that we generate. So then we also will produce filament yarns with the recycled materials. We will produce the filament yarns. So we are a yarn producer, so we have different plants. So we mainly produce polyester, PVT, polyamide, polypropylene, continuous filament, and some staple fibers also mainly for non-wovens applications. So that we will be able to close the loop with the partners for the weaving. So IBQ in this case is the weaver that will go on the chain after us. And then also do some assessment on the recyclability and eco-design with the rest of the partners to tell them what's better to use or not. So Where2Go has done a first step in the separation of material, which is to separate those materials which are reflective tapes, buttons, or anything that has to be separated will be a first important step, but then we will have to see what remaining, what can we do, are there coatings, are there finishings, is it 100% polyester, so what can we do with all this? So mechanical recycling, thermomechanical recycling, this is what we are talking here. So it's a system that finally it's all a matter of mechanical action. So we cut, we melt, we granulate, so it's just changing shapes. So that's why it's called mechanical. So we will be entering textile waste. It enters and tries, there's a feeding, there's a little bit of gas extraction, there's extrusion, there's important filtering, and then there's a granulating. We take the polymer and we granulate. So finally, what comes in, comes out. So except some impurities that we will filter, but if what enters is colored, what comes out is colored. So here in this case, we are not removing color. Also to other mechanical recyclings, which are shredding fibers. Many times the mechanical recycling, which is taking fibers, shredding, and then making fiber, staple fiber again. In this case, where they can separate the blues, the reds, the greens. In this case, in continuous filament, we cannot do this. The volumes we need in continuous filaments are very big. We cannot do green and blue and red, and then we make a blue yarn and a green yarn. We cannot do it by volumes, and we cannot do it because many times lots of those dyestuffs, colors, are soluble dyestuffs. They are dispersed dyes that we put in yarn dye or in fabric dyes. Those dyestuffs are not ready to pass 290 degrees. Most of them will sublimate. So maybe you are starting in a red color and what you get is brown because part of the formula of the dyestuff is going to change. So it would make no sense to separate by color. So we cannot do this. So we mix everything, we recycle, and we get something that is mixture of colors. What can we do with it? We can saturate to black. So we can homogenize it by adding dope dyed carbon black master batch and have a regular black. So this is a good option. This is existing now. We have a plant here. We are recycling from 10 years now all our internal waste. We are recycling it within Antex. We are starting recycling customers' waste and some customers of our customers' waste. So more thinking in post-industrial waste mainly because post-industrial waste, it's easy to know what it is. Everyone knows in their plant what you are producing, every machine what is producing, so it's easier to do. So this is one of the options and this is one of the products. But of course it needs to be 100% polyester. If you have cotton, you have a problem. Cotton is not going to melt. It will be an impurity, so it's not a thermoplastic. We cannot mix too many things, so it has certain limitations. That's why to absorb these limitations, we need something else. So chemical recycling sounds very bad. It's like chemical, wow. So it's chemical because it happens chemical reactions. So the other one was mechanical reactions, one after the other, cutting, shredding, melting, so on. In this case, you need a chemical reaction to dismantle the polymer, let's say so. And it's complementing the mechanical recycling. So I really think that it will be needed to solve the textile problem. So because textile waste, it's more complex, even the packaging waste. So it's really complicated. We have garments with elastane, with cotton, with a little bit of viscose, a little bit of wool, a little bit of polyamide. So it's really complex. So I mean, we will need those kind of recyclings to be able to solve this problem. So in this case, what we are doing in this project, we are doing the glycolysis. There are different systems, probably maybe you have heard of hydrolysis, methanolysis, glycolysis. So in this case, depending on what you use to make the reaction, it will be one type or the other, and the output will be different. But well, all of them are valuable depending on what you want to get. Here, what we are doing is a glycolysis reaction. So finally, it's the polyester with glycol and a catalyst and heat. We are making a reaction. So we are like dismantling the polymer. So a polymer, it's polymer, poly, a lot, various. So polymer, so it's a molecular chain of different monomers. And what we have to do is dismantle it. It's like a Lego house, if you had a Lego house. And then you dismantle and you have again the Lego pieces and you can make another new house. So we have to dismantle into the monomer, so in this case. So we are taking the waste, we are grinding and then doing the depolymerization. We are getting the monomer, which is the single pieces. And then we will have to make a polymerization to make, with a monomer, several monomers, make a polymer. So we will make a polymer. We will get PET granulates, and then we will make, again, polymer. Yes, it will absorb more energy than mechanical recycling, but less than starting from zero. So, I mean, we will avoid having waste. It consumes the LCA, it's better than starting from zero, petrol, blah, 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 until polymer. So, and it's complementing the mechanical recycling. It's not substituting, it's complementing. So here in the project, we have done different trials in the chemical recycling to see the feasibility and to see how, at the moment until now, it's on lab scale. And then at the end, once we see the results and what are the best products to chemical recycling, we will do one batch of 200, 300 kilos so that we are able to make yarn again and fabrics out of the yarn again. So to be able to do a circular and close a loop. So in this case here, the sample one is 100% polyester fabric, so, but in a fluo yellow. Fluo yellow is not the easiest color to remove also. So here it was, well, it was in the way round, but well. We did the first monomer, still had certain, first it was the oligomers that we retained. We got the monomer, but it's still highly colored because dye stuffs are difficult to remove. Then we had to work quite a lot to remove color of the BHET, which the BHET is the monomer, and finally to be able to get a white monomer. So in difference to the mechanical recycling, if it was colored, it was colored. So in chemical recycling, we would be able to remove, I mean, it's something challenging and difficult, and also depends if it's soluble dye stuffs, if it's master batches and pigments. So every option has different solutions, but it will give us the possibility to really go to something white. Because if we want to make a fluo yellow jacket, we need something white. We cannot start from something black to make a fluo yellow. So finally, we will need somehow also to be able to do white material again. In this case, here it was a little bit more challenging. So instead of 100% polyester, traditionally in workwear, there's a lot of membranes. Of course, I mean, workwear, they need a hydrophobic, they need membranes for the use they usually have. So usually it's polyurethane membrane. So polyurethane and polyester, it's not even of the same family. So here there's a challenge. And it's something that where to go cannot separate because they are intimate bond one to the other. So here we have a problem. So, but anyway, we wanted to see what was the result of what usually is being used. So we did also the glycolysis. We obtained the oligomers, the monomer, highly colored. We were coming for a fluor red. Then we were able to remove the color, but then here we can see some kind of contaminations in the monomer. This is the polyurethane membrane. So probably industrially then, if finally one day it has to be recycled, we would have to see how we could filter and remove this polyurethane from the monomer to be able to have a more pure monomer that can be polymerized back into a good polymer. Here, as improvement in the project, we are switching from polyurethane membrane to a polyester membrane. So here it was the idea was to see, is it this effort that the industry is doing, is it worth? Is it going to give something better? So here we also took the textile sample. These are the oligomers that were retained. The monomer, before removing color, the monomer first color removal process, and then finally the last removal process. So here we don't see those impurities. The fact of being from the same family, the membrane, being polyester membrane, is giving less impurities on the final product. So it seems that really it's something that can help. But it's important to know both of them, because even if we start today changing membranes, the garments that we will be recycling in the 5 to 10 years, we always have to think that it will be what we were doing before. So even if we start today, we have to be ready for what was from yesterday. So that's why we are seeing also what problems could bring the fact of you having polyurethane membrane. Oh, sorry. Okay, finished. See? Oh, thank you for your attention. Well, any questions? Well, I think it was more or less this, so thank you.
There is time for 1 or 2 questions, if there are questions in the audience. Can you wait? My colleague will come to you with the microphone. Thank you.
Stage is Antex, because you say it's in trial, but in what stage you are to make it in bigger volumes?
So mechanical recycling is on place, and it's something that we are doing. Chemical recycling, there are different initiatives around Europe starting with chemical recycling. But lots of them are focusing a lot on the packaging industry, not so much on the textile, because textiles we are a bit ahead. Well, it's like more complicated. It's better sometimes to start on other things. That's why we want to develop the technology and see with what we get potential partners. Our intention would be to start doing some tones trials in the next months, either using technology from industries that nowadays they exist, because sometimes there's processes that we need that maybe are not in the textile industry, but they are in other industries, but would work. We can use their infrastructure to make those processes. So we are now in lab scale. We have done some, in other textiles, some 500 kilos, 1 ton trials. And during this period, we would like to start doing few tons trials, but it's all in semi-industrialization, but not yet industrial. So.
Okay. Yeah, thanks.
So I'm interested in the separation part, so where to go. Okay. Now what I mean is not the separation of the button or elastin or whatever, but it's more the separation of different types of polymers. And in the presentation of Antex, you mentioned that polyurethane and polyester you cannot remove.
That's right.
Yeah. So my question is, what will be the limitation? What can you remove? What you cannot remove? Especially in the perspective of different types of polymers.
Okay. I think that you have to rethink some things, because everybody which must be attached to, let's say, clothing to make it, let's say, more protective or let's say more fashionable. Sometimes by colors, sometimes by different materials, sometimes by a tag or something by etc. So think in that environment. So everybody you like to add on the product, stitched, think in the way of stitching, with where to go, we can disassemble, no problem, in this system. When we are talking about or looking at, let's say, upcycle of some materials, if we are talking about, let's say, the high-vis materials we are using now in this project, recycling is the best, not upcycling. So the materials we are removing, it depends on the materials, what we can do with it, or recycling, or upcycling. In the case of Circtex, we are, of course, in the case of upcycling, closing the loop. But it could be, and we are not a favorite of it, but it could be that some materials, we can do anything with it, besides to take it away, to disassemble. But of course, the benefit is that the materials which will stay, or the monomaterials, are really monomaterials, and in that monomaterials we can think about upcycling. And of course, when we are thinking about polyester, yes, that's possible, but when we are talking about, let's say, 80-20% polyester cotton, for instance, yeah, that's still a little bit of a problem. But in our platform, that's progressive, means that we are capable when there are things available that we really can think about upcycling of products which aren't upcyclable at this moment. We can change in the passport, so let's say in the traject a little bit further. Everybody who can read, let's say, the information knows what can be done with that kind of product. So it's dynamic, the passport, and the information behind it. But back to your question, no, only products which are stitched to it, we disassemble, and it depends a little bit on the product if we can upcycle, yes or no.
Hi, I also have a question.
Okay.
Concerning the process of the assembly. When you're disassembling, I mean the yarn is not polyester, right?
The yarn?
The
Okay.
yarn.
Okay.
So when you disassemble in a microwave, the yarn breaks. And what happens to the really small pieces that stay in there? Is it not really time-consuming to get out all the small bits
That's
and
a
pieces?
very good question, because that's really the case. But maybe one thing to make clear a little bit better, when we are talking about the wear 2 yarn, the wear 2 yarn is a polyester yarn, full stop. Okay? Only the inside is a different material, the core. And we discussed it an awful lot in the project. Yes, indeed, at the end, by disassembling, some residue or rest material from the yarn will stay, that's right. But it's only a very small amount, I can tell you. And in our project, we discussed an awful lot. It's no problem in case of upcycling. So that's the real answer. Thank you.
Thank you very much.
Yeah? Thank you all. Thank you.